Dear students, in the last class we learnt about the DsP2 hybridization and sp3 hybridization. DsP2 hybridization, it is the square planar shape. Here they are not giving a compound, they are giving a complex. It means the central metal ion bonded with the ligands. This central metal ion is positive and the ligand is negative and the neutral. Here the complex is tetracyanonickel complex. In that, cyanide is the ligand and it behaves as a Lewis base. It donates a electron pair. Okay. Next, here we have to know about that cyanide makes a bond with nickel. So nickel provides 4 vacant orbital because the cyanide gives a electron pair, so that's why it makes a vacant orbital. But other molecule, they need a unpaired electrons. Okay, the orbital should contains a unpaired electron. In that, we have to know about the outermost electronic configuration of nickel and the oxidation state of nickel. Okay, this is the outermost electronic configuration of nickel after the loss of electron, and here cyanide is the strong ligand. The pairing will be possible, so that's why here I am writing 4p. Okay, here there are 4 cyanide ions is there, so that's why we need a 4 vacant orbital dsp2. Here 4 dsp2 hybrid orbital is bonded with the nickel. This is the structure of tetracyanonickel 2 complex, square planar. Okay, next, fourth one is sp3 hybridization. This is tetrahedral. Here intermixing of 1s and 3p orbital is called it as a sp3 hybridization. Here formation of silicon tetrachloride. Silicon, the electronic configuration of silicon is 3s2 3p2. Here one of the electron presence in the 3s, that should be promoted to 3pz because we need a 4 unpaired electrons to bond with the 4 chlorine atom. Okay, here this 4 sp3 hybrid orbitals bonded with 4 chlorine atoms to form 4 sigma bond. Okay, this is all about the last class. Then now in today's class we learnt about the the fifth one hybridization is sp3d hybridization. sp3d hybridization means intermixing of 1 s orbital, 3 p orbital and 1 d orbital. This is called it as a sp3d hybridization. The shape of the molecule is trigonal bipyramidal. Trigonal bipyramidal. Okay, here the example is formation of phosphorus pentachloride PCl5. Okay, here we have to know about the outermost shell electronic configuration of phosphorus. The electronic configuration of phosphorus is 3s2 3p3. Okay, the outermost shell electronic configuration of phosphorus. Okay, then the box type electronic configuration is 3s 1 2 3 px py pz. This is 3p. How many electrons are present in s orbital? 2 electrons. Then 3 1 2 3. Okay, here you have to observe this. There are 5 chlorine atoms are bonded with the phosphorus. 5 chlorine atoms bonded with phosphorus. So it needs 5 unpaired electron. Okay, 5 unpaired electrons. So here there are only 3 unpaired electrons are present. We need 5 unpaired electrons. Okay, so that's why in the next step there is 3s. Next is px, py, pz, 3p. Then next member is d orbital. D orbital contains 5 suborbitals. Okay, that is dxy, dyz, dzx, dz square minus x square minus y square, dz square. Last one. Okay, here 3s has 2 electron and px, py, pz. In this step, one of the electron present in the 3s that should be bonded with the, that should be promoted with the dxy. Okay, another 3d orbital. Okay, here there are 2 electrons present in the s orbital. In that, one of the electron should promote it to the d orbital. So the electron is 1s, 1 2 3, 3p, 1 2 3. Next is 3d, 1 2 3 4 5. Here one electron should promoted to 3d orbital. So here how many electrons are present? Sorry, how many unpaired electrons are present? 1 2 3 4 5. Okay, 5 unpaired electrons. Unpaired electrons. Here how many s orbital is there? 1s. How many p orbital? 3, sp3. How many d orbitals? D. Here the hybridization is sp3d hybridization. How many unpaired atomic orbital is present? 1 2 3 4 5. Okay, these 5 sp3d hybrid orbitals bonded with okay, chlorine atom. These sp3 hybrid orbital of phosphorus should bonded with 5 chlorine atoms. Here you have to see in the example PCl5. There is 5 chlorine atoms is bonded with phosphorus, so it needs a 5 unpaired electrons. So here also 5 sp3d hybrid orbitals are present. This is the Lewis dot structure of phosphorus pentachloride. By writing the electrons in dot type, that is called it as a Lewis dot structure, and this is the actual structure of phosphorus pentachloride, and the bond angle between these two is 90 degree. The bond length is 214 pm. Pm means picometer. The bond angle is here also 120 degree. This bond length is 202 pm. Okay, this is all about the sp3d hybridization. You have to know about that formation of phosphorus pentachloride. Okay, next we will move on to the sp3d2 hybridization. This is the last hybridization, that is sp3d2 hybridization. The sp3d2 hybridization means intermixing of 1s, 3p, 2 d orbitals. This is called it as the sp3d2 hybridization. The shape of the molecule hybridization is octahedral. The shape of this hybridization is octahedral. Okay. The example for this hybridization is formation of SF6 molecules. It means sulfur hexafluoride. The atomic number of the outermost electronic configuration of sulfur is 3s2 3p4. How many electrons are present in the outermost shell? 4 plus 2, 6 electron. Okay, here 3s, next 3p. p orbitals have 3 suborbital, px, py, pz. This is 3p. In that you have to write 1, 2, and p as a 4 orbital, 1, 2, 3. According to Hund's rule of maximum multiplicity, you have to fill the electrons 4. 1, 2, 3, 4. Okay. In that, how many unpaired electrons should need to bond with fluorine atom? 6 unpaired electrons. So that's why here there are 2 unpaired electrons are there. We need 6 electrons. So that's why 3s, 3p, next is 3d. Okay, d orbital has 5 suborbitals. Okay, 3p, 3d. In that 3s has 2 electron, px has 2 electron, 1, 2. Okay, in that 3s electron, one of the electrons should move towards the d orbital, and in the 3p, px electron, in that one of the electrons should move towards the d orbital. Okay, so here there are 2 paired electrons are there. In that one electron should move towards the 3d orbital. So the outermost electron is 1, 2, 3, 2, 3, 4, 5. 1, 2. Okay, 3d, 3p, 3s. In the 3s, the 1 electron should move towards the d orbital. Here also 1 electron should move towards the d orbital. So how many unpaired electrons orbitals are present? 1, 2, 3, 4, 5, 6. 6 unpaired electrons are present. 6 unpaired electrons are present. So here how many s orbitals are there? 1, 3 p orbitals are there, sp3, 2 d orbitals are there, sp3d2 hybridization. Okay, there are 6 hybrid orbitals are present. Hybrid orbitals are present. So these orbitals are bond with 6 fluorine atoms. Okay, the shape of the orbital is F, 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 F. Okay, this angle is 90 degree and the bond length is 158.4 pm. Okay, this is all about the sp3d2 hybridization. This is the example. Okay, this is all about the types of hybridization. Okay, next we will move on to the resonance structure for inorganic compounds. Okay, resonance structures for inorganic compound. Here we are talking about resonance structures. Resonance structures for inorganic compound, not a organic compound, inorganic compound. Okay, here resonance structures for inorganic compound or inorganic molecules means, resonance structure means there will be written in Lewis dot structure. Lewis dot structure. Okay, it means that the structure of the molecule should be written in the Lewis dot structure. In that, formal charges are maybe change. Formal charges are maybe change. It means formal charges means, for example, carbon as +4, sodium as +1, or it may be, these will be changes. Here some rules are there to write the resonating structure. Rules to write a resonating structure. This is for inorganic compound, not a organic compound. Okay, resonance structure. Okay, some rules are there to write the resonance structure. Okay, then first one is, before going to that, we have to know about the what is delocalization. Okay, what is delocalization? In resonance structure, the electrons are able to move to help stabilize the molecule. Okay, this is called it as a, this is called delocalization. Okay, it means for writing the resonating structure, in that the electrons are able to move to help stabilize the molecule. Here, for writing the resonating structure, that electron should always be in the moving position. Okay, it is not a fixed position. In that, which electrons are moving means pi electrons, or lone pair of electrons are Okay, which electrons are moving means pi electrons, or lone pair of electrons. Pi electrons means pi bonding formation. Pi bond form ಆಗಿರುತ್ತಲ್ಲ, ಆ pi bond form ಆಗಿರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ pi electrons ಅಂತ ಕರೀತಾರೆ. Here sigma electrons does not move because that is fixed. Okay, here pi electrons or a lone pair of electrons are delocalized. It means that will be move around the molecule. That molecule should stabilize us. It means which molecule has a more resonating structure, that molecules has more stabilized. Okay, it means more stable molecule. Okay, next we will move on to the rules. First one is, the rules for the writing a resonance structure is, first rules is, resonance structure should have the same number of electron. Here do not add or subtract any electrons. It means if oxygen has 8 electrons, we have to write the resonating structure for ozone, O3. In that, O3 means 8 3s are 24 electrons. Okay, there will be only 24 electrons are present. There is no addition or a subtraction will be takes place. Okay, it means here it not get a loss or a gain of electron. Next, second one is all resonating structure must follow the rules of writing Lewis structure. It means all the resonating structure, by writing the resonating structure, that should be in the Lewis dot structure. It means in the hybridization, here this is the Lewis dot structure. Okay, in that we have to write a resonating structure like this. And third one is the hybridization of the structure do not change. It means if it is electron will be move, it means delocalization will takes place. In that the only the electron will move, not the hybridization or a bond will be changes. Okay, next, the skeleton of the structure cannot be changed. It means how many bond pairs are present should be present, and how many lone pair of electrons that should be present. ಅಂತಂದರೆ ಎಷ್ಟು ಬಾಂಡ್ ಪೇರ್ ಇರುತ್ತೋ ಅಷ್ಟೇ ಬಾಂಡ್ ಪೇರ್ಸ್ ಇರುತ್ತೆ, ಎಷ್ಟು ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೋ ಅಷ್ಟೇ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಆಯಿತಾ? ಇನ್ ದಟ್ ದ ರೆಸೊನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ ಮಸ್ಟ್ ಆಲ್ಸೋ ಹ್ಯಾವ್ ದ same amount of lone pairs. It means which amount of lone pairs are present when the delocalization is takes place, that amount of lone pairs are present only. Okay, either it is add or it is a donate. For example, there will be one illustration is there for ozone molecule. You have to observe for ozone molecule, molecular formula is O3. The structure of ozone is double bond O, single bond O. Okay, here you have to observe for oxygen it is 8, 1s2, 2s2, 2p4. How many electrons are present in the outermost shell? 6 electrons. In that 2 bond pairs and 2 bond pairs and 2 lone pairs are present. Okay, in that you have to observe here, this is the 1 oxygen atom, this is 2, this is 3 oxygen atom. All the oxygen atom, this oxygen atom also contains 2 bond pair and 2 lone pair. This also contains 2 bond pair and 2 lone pair. This also contains 2 bond pair and 2 lone pair. Okay, here you have to observe this for first oxygen atom. How many bond pairs are present? 1, 2, 3. Okay, here oxygen, first oxygen atom that contains only 1 lone pair of electrons. In that one of the lone pair of electrons should donate the electron and share with the third one oxygen atom and form a bond pair. Okay, do you get it? ಇಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ ಅಂತಂದರೆ 3 ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಇದೆ. ಆ 3 ಆಕ್ಸಿಜನ್ ಆಟಮಲ್ಲೂ ಒಂದೊಂದು ಆಕ್ಸಿಜನ್ ಆಟಮ್ಗೂ 2 ಬಾಂಡ್ ಪೇರ್ ಇರುತ್ತೆ, 2 ಲೋನ್ ಪೇರ್ ಇರುತ್ತೆ. ಅದರಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ ಅಂತಂದರೆ ಈಗ ಫಸ್ಟ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ 3 ಬಾಂಡ್ ಇದ್ದಾವೆ, ಆಯಿತಾ? ಬಟ್ ನಾನು ಹೇಳಿದ್ದೆಷ್ಟು 2 ಬಾಂಡ್ ಇರಬೇಕು ಅಂತ. ಸೊ ಇದರಲ್ಲಿ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಇದೆ. ಎಕ್ಸ್ಟ್ರಾ ಹೇಗೆ ಫಾರ್ಮ್ ಆಯ್ತಪ್ಪ ಅಂತಂದರೆ ಈ ಫಸ್ಟ್ ಆಕ್ಸಿಜನ್ ಆಟಮು ತನ್ನಲ್ಲಿರುವಂಥ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಥರ್ಡ್ ಒನ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಜೊತೆಗೆ ಬಾಂಡ್ ಆಗುತ್ತೆ, ಆಯಿತಾ? ಹಾಗಾಗಿ ಒಂದು ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ನ ಕಳ್ಕೋತು. ನೆಕ್ಸ್ಟು ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಆಕ್ಸಿಜನ್ ಆಟಮಿಗೆ ಬರೋಣ. ಎಷ್ಟು ಬಾಂಡ್ ಪೇರ್ ಇದೆ? 2 ಇದ್ದಾವೆ. ಹಾಗಾದರೆ 2 ಲೋನ್ ಪೇರ್ ಇರುತ್ತಾ? ಓಕೆ, ಇದು ಕರೆಕ್ಟಾಗಿದೆ. ನೆಕ್ಸ್ಟು ಥರ್ಡ್ ಒನ್ನಿಗೆ ಬರೋಣ. ಥರ್ಡ್ ಒನ್ನಲ್ಲಿ ಏನಿದೆ? ಕೇವಲ ಒಂದೇ ಒಂದು ಬಾಂಡ್ ಪೇರ್ ಇದೆ, ಇನ್ನೊಂದು ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಿಲ್ಲ. ಆ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಿರಲ್ವಲ್ಲ, ಆ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗದೇ ಇರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ಗಳು ಲೋನ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗಿ ಉಳ್ಕೊಂಡಿರುತ್ತೆ. ಗೊತ್ತಾಯ್ತಾ? ಇಲ್ಲಿ ಇನ್ನೂ ಒಂದು ಬಾಂಡು ಫಾರ್ಮ್ ಆಗಿರಲ್ಲ, ಸೊ ಹಾಗಾಗಿ ಒಂದು ಲೋನ್ ಪೇರ್ ಆಗಿ ಉಳ್ಕೊಂಡಿರುತ್ತೆ. ಗೊತ್ತಾಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಇದಕ್ಕೆ ನಾವು ರೆಸೊನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ನ ಬರೆಯೋಣ. ಇಲ್ಲಿ ರೆಸೊನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಓಝೋನ್ ಮಾಲಿಕ್ಯೂಲ್. Okay, here this has only one lone pair, and here it has two lone pairs, and here it has three lone pair of electron. ಇದರಲ್ಲಿ ಯಾಕೆ 3 lone pair ಇರುತ್ತೆ ಅಂತಂದರೆ ಒಂದು ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಿರಲ್ಲ. ಓಕೆ, ಆ್ಯಂಡ್ ಇಯರ್ ಯು ಹ್ಯಾವ್ ಟು ಅಬ್ಸರ್ವ್ ಇಯರ್ ಎಷ್ಟು ಬಾಂಡ್ಗಳಿದ್ದಾವೆ? 1 2 3 ಬಾಂಡ್ ಪೇರ್ಸ್ ಇದ್ದಾವೆ. ನೀವೇನೇ ಚೇಂಜ್ ಮಾಡಿದ್ರೂ ಬಾಂಡ್ ಪೇರ್ಸ್ಗಳು ಚೇಂಜ್ ಆಗಕೂಡ್ದು. ಆಯಿತಾ? ಎಷ್ಟು ಬಾಂಡ್ ಪೇರ್ಸ್ ಇರುತ್ತೋ ಅಷ್ಟೇ ಇರಬೇಕು, ಎಷ್ಟು ಲೋನ್ ಪೇರ್ಸ್ ಇರುತ್ತೋ ಅಷ್ಟೇ ಇರಬೇಕು. ಈಗ ಲೋನ್ ಪೇರ್ಸ್ನೂ ಲೆಕ್ಕ ಹಾಕೊಳ್ಳಿ. ಒಂದಿದೆ, 1 2 3 4 5 6. ಓಕೆ, 6 lone pairs and 3 bond pairs are present. Okay, in that you have to observe here, this electron should goes here. Okay, this 2 electrons should goes here, and this electron should comes with oxygen atom. Okay, next the resonating structure of this is the first resonating structure. Here there are 2 possible resonating structures are there. Oxygen atom here 1 2 3. Okay, here ಇಲ್ಲಿರುವಂಥ ಬಾಂಡ್ ಏನಾಗುತ್ತೆ? that should be goes to the second oxygen atom, so it contains as a lone pair of electrons. In the third oxygen atom, one of the lone pair of electrons should form the bond. Here it gets a 2 lone pairs. Here this oxygen gets a 3 lone pairs, and this oxygen gets a 2 lone pairs. Here this is the lone pair of electrons. This should be delocalized. Delocalization means moving of electrons. Here this is the pi bond, it means pi electrons. This electron should move. Here the moving electrons only for delocalization means moving of electrons. That moving of electrons only from pi electrons or a lone pair of electrons. This is the resonating structure of ozone molecule. You have to calculate bond pairs also. 1 2 3 3 bond pairs. 1 2 3 4 5 6 lone pairs are present. Here there is no addition of electrons takes place, or subtraction of electron should takes place. Okay, here there is no addition and subtraction will takes place. So this is the resonating structure, for example. Okay, in the next class we will learn on the other example. You have to observe this. In that there will oxygen has the 2 lone pairs and a 2 bond pairs. Here this oxygen has 3 bond pair, so that's why one of the lone pair is sharing with this oxygen atom. This oxygen atom has only 1 bond pair, so that's why it carries a 3 lone pairs. Here this is the right. In that some resonating, there will be 2 resonating structures is possible. This will be the this electron should form the bond, and this bond goes to this oxygen atom. So this is the second resonating structure. If more number of resonating structure is there, that molecule is more stable. Okay.